Hello everyone, in this last third lesson of two streams unit we're gonna talk about energy targets. In the temperature versus delta H diagram, if we want to study the recovery between a hot stream and a cold stream for a specific minimum approach, this time in the left, in the cold side of the heat exchanger, and if the heat transfer is correct, then the minimum heating will be this extension, this duty, the part of the cold stream that is not covered with hot stream, and the minimum cooling, the minimum refrigeration will be this duty, this gap, the part of the hot stream that has not a cold stream to pass to. The part of the heat transfer where the hot stream is over the cold stream with at least a minimum difference in temperature equal to the minimum approach. This is the process-to-process heat transfer. This is heat transfer between process streams to mark the difference with utility heat exchange. Then, just knowing the stream, temperatures and duty, and without detailed design, we can have an idea for a minimum approach on how much cooling, how much heating we will need, and also how big the heat transfer area process to process will be. These are energy targets, the minimum need for these two streams that we will use of heating and cooling. Not only the flows, the amounts are known, but also the levels, the utility levels. It is for the job to be done, we will need heating from this temperature to this final temperature, and we will need cooling from this temperature to this final temperature, which give us what temperature will have the heating and the cooling utilities. Remember how important is the value of the minimum approach. If this gets bigger, then the two streams will be more separated, the process-to-process heat transfer will be smaller, and the heating and the cooling would have to be bigger. One last concept of interest is that of a remanent problem. When pairing two streams, we can eliminate completely the needs of hot and cold. It is the needs of the hot exactly equal to the needs of the cold. This is one possibility. Another one is to eliminate completely the need of one of them. Imagine, for example, a big hot stream and a short cold one. Then, when pairing, the needs of the cold stream are completely eliminated. Or the most common is to eliminate partially the need of hot and cold. In this case, a chunk of every stream remains. Then, for the future, when you match two streams, a part of them is completely solved and forgot, and there is a remnant problem, a couple of chunks of stream that remains.